Okay, we're going to start with the concept of raw data. Raw data is the numerical and or non-numerical value of information or observations before it is arranged or analyzed in a useful manner. Statistics involves the procedures associated with the data collection process, the summarizing and interpretation of data, and the drawing of inferences or conclusions based upon the analysis of the data. So raw data, for example, could be a collection of ages from a particular class of people. Let's say we have a statistics class here online. If I collected everybody's ages, that would be considered raw data, because I have not yet added up those ages and calculated an average. I haven't calculated a range. I haven't divided up the ages into groups or made any kind of conclusion at all. I've just collected it. And say if I put it in a long list and I distribute it, then you have a collection of raw data. We've not yet done anything with the data, and that's why it's considered raw. What we do in statistics is we take this raw data and then we do stuff to it. We'll calculate a mean, calculate a percentage, categorize the data. We may create graphs or charts. And so statistics takes raw data, does something to it, so that therefore the end result is a way to draw conclusions about the data. So here's what we have. We start with raw data, collections of numbers or facts that are not tallied in any way. Then we do some sort of statistical analysis on that data, which involves doing some sort of math, and the math that we're going to be doing is what we cover in this course. And then what we get out of that process is some sort of conclusion about the data. So if I were to collect everybody's ages in this class, that would be considered the raw data. If I were to then calculate the mean or the average of all the ages, that's the process of analyzing the data, conducting a statistical analysis on the data. And then if I conclude that most of the students in this class are between 18 and 35 years old, that is a conclusion to the statistical analysis. And that's basically what statistics is. Okay, descriptive statistics uses numerical and or visual techniques to summarize or describe the data in a clear and effective manner. So here's an example of descriptive statistics. This is in your textbook. It's figure 1.1 from chapter 1. There's a picture of a hockey stick and two hockey pucks. Beneath the two hockey pucks are dates. So we have 1971-72, 1994-95. Now, the hockey puck above 1971-72 says 5'11", 184 pounds, and the hockey puck above 1994 says 6'1", 202 pounds. The title, NHL, National Hockey League as a Growth Industry. Now, what descriptive statistics does for us is it paints a visual picture of data. So what we have here is we are told that the average height and weight of an NHL player in 1971-72 was 5'11", 184 pounds, whereas the corresponding height and weight for an NHL player in 1994-95 is 6'1", 202 pounds. The conclusion that we can make from this snapshot is that the height and weight of NHL players has grown from 1971-72 to 1994-95. So verbally, we can state the average NHL player in 1971-72 was 5 feet 11 inches tall and 184 pounds. The average NHL player in 1994-95 was 6 feet 1 inches tall and 202 pounds. Okay, if this data were given in a long list, for example, if we collected all the heights and the weights of players from 71-72 and 94-95 and had it in its raw data form, it wouldn't be too helpful. But looking at it as a picture, which is figure 1.1 in your text, helps to comprehend the size of these players quickly and easily. So descriptive statistics gives us a visual interpretation of some sort of collection of data. Okay, we talk about the idea of a population very frequently in this class. The population is the entire collection of all individuals or objects of interest. For example, if we were looking at the NHL example just previously, the population would be all NHL players. The sample, however, is different. The sample is a portion of the population that is selected for study. What we do in inferential statistics is we take sample information and we draw inferences or conclusions about the population based upon the sample. So, for example, a medical researcher wants to determine if large doses of vitamin C are effective in combating colds and uses a sample of the entire population to test this theory. So if we think about this example here, the population that the medical researcher is probably referring to is people, all people. Do we want to see if vitamin C is effective in combating colds in people? But it's impossible to test this out on every single person. Therefore, we take a small sample, just a collection from the entire population, and we use that sample to make a conclusion about the effectiveness of vitamin C in combating colds. So what we do is, again, we start with a population, everything of interest. It could be people, it could be animals, it could be products. A lot of times we'll be dealing with inventory of products. When you can't test out on the entire population, we take a sample of the population and we study the sample. It's always smaller. The sample is always smaller than the population. This branch of statistics called inferential statistics. Inferential, you can see the word inference in there, which is about coming to conclusions. Inferential statistics takes sample data and makes a conclusion about a population. So let's take a look at an example. A representative sample is a sample that has the pertinent characteristics of the population in the same proportion as they are included in that population. So for example, let's suppose that our population is the entire U.S. population. And then we take a sample of this entire U.S. population, but our sample only contains 18 to 24-year-old college students who are only male. Well, that sample is non-representative of the entire U.S. population because we're not sampling both genders, we're not sampling all age groups, and we're not sampling people who don't go to college. So a true representative sample of the U.S. population would contain all genders, all ages, all races, etc., that are present in the United States. So when you sample, you have to make sure that the sample is truly representative of the population. A statistic is a number that describes a characteristic of a sample. For example, let's suppose our class is a sample of the entire NCC population. Then the statistic could be the percent of female students in the class. Another statistic could be the percent of male students in the class. Another statistic could be the average age of all students in the class. On the other hand, if we're looking at a population of data, the parameter is a number that describes a characteristic of a population. So instead of looking at just the sample, now we're broadening our view and we're looking at the entire population. So let's suppose that the entire student population of NCC is considered the population that we're studying. Then the percent of female students attending NCC would be the parameter. So when you're looking at a sample, the percent of female students is considered to be the statistic. When you're looking at an entire population, the percent of female students is considered a parameter. We're going to look at this example 1.2 from your textbook, and we're going to decide what's the population, what's the sample, and whether or not 52% is a parameter or a statistic. So here's the example. A politician is interested in determining the proportion of 20,000 voters within her district who will vote for her in an upcoming election. An opinion poll of 1,500 potential voters was taken to estimate how all the voters in her district will vote in the upcoming election. The results of the opinion poll indicate that 52% will vote for the politician in the upcoming election. So part A, what's the sample? So remember that part A, what's the population? Remember, the population is all objects of interest, all of them. Okay, the sample is a portion just taken for study from the population. And part C, is 52% a parameter or a statistic? Now remember, if it's a parameter, the 52% is an indication of how many people will vote for the politician from the population. If it's a statistic, the 52% is a representation of the proportion of people who will vote for the politician from the sample. So we have to decide, are we talking about a sample or a population? So part A, the population of this example is all 20,000 voters in her district. This is the entire district. Everybody in the district comprise the population. The sample, however, is that portion that's taken for the study, or the portion that's taken for the poll. The 1,500 potential voters that were polled represent the sample. So the population is the bigger piece, the sample is the smaller piece that has been selected for study. Now, that 52%, does it represent or is it taken from the sample? Is it a calculation from the sample, or is it a calculation from the population? Now, since it's from the sample, you have to read the words of the problem, that 52% is taken from the sample, therefore 52% is a statistic. It's a statistic since it describes the characteristic of the sample of 1,500 potential voters. Now, if on the other hand, it represented all 20,000 voters in the district, then it would be considered a parameter. Okay, so